We're now going to do Unit 5, Lesson 2, Properties of Parallelograms. So we're going to just focus on parallelograms right now. Recall the definition of a parallelogram. And we said that a quadrilateral is a parallelogram if and only if both pairs of opposite sides are parallel. And we're going to kind of explore this a little bit in order to get some properties of parallelograms. So I'm going to take this triangle ABC, I'm going to rotate it 180 degrees about the midpoint of segment AC. Sorry, I have the midpoint drawn, and 180 degrees is going to flip this upside down. It's not going to be perfect. So this is going to be B prime, and then that would obviously be A prime and C prime if I were to rotate it. Using the definition of a parallelogram, how could I prove that ABCB prime, so ABCB prime, so this shape is a parallelogram? And I'm actually going to make these lines. Again, it's not perfect. We can prove ABCB prime is a parallelogram. Again, we can use that as our abbreviation by. And so what you need to do is, we just said that by definition, a parallelogram has both pairs of opposite sides parallel. And so I need to show that both pairs of opposite sides are parallel. If I can show that both pairs of opposite sides are parallel, then I can show that it's a parallelogram. So how can I show that both pairs of opposite sides are parallel? And if you kind of look at our picture here, this should kind of look familiar. We spent a whole unit on Unit 3 doing problems like this with parallel lines. And the converse of angles like this was if alternate interior angles congruent, then parallel lines. So if I can prove that both pairs of alternate interior angles are congruent, then I can show that both pairs of opposite sides are parallel. So we can prove ABCB prime is a parallelogram by showing both pairs of alternate interior angles are congruent. If alternate interior angles congruent, then parallel lines. Again, I didn't expect you to figure all that out on your own, which is why I kind of did that a little bit for you. You're not going to have to do that on your own. What you are going to have to do is know these properties that I'm going to come up with 1 through 6, and you're going to have to know them very, very well. I'm going to go over them right now. My advice to you is to take these properties, put it on a note card, and start studying them. Because the more you know these properties, the better off this unit's going to be for you, because these properties drive everything home that we're doing in this unit. So what's going to happen is, using what you know about transformations and congruent triangles. So right now, these triangles are congruent. The reason I know they're congruent is because we've learned that rotation is an isometry. And a rotation being an isometry does not change angle measure or side length. And so that's what I can start with. I know that these triangles are congruent. And so using what I know about transformations and congruent triangles, well, I know the triangles are congruent. And so then what do I know about congruent triangles? With congruent triangles, I know that all corresponding parts are congruent. So that means I know that all 3 angles and all 3 sides are congruent. So I'm going to kind of take all that information and pull it together and answer 1 through 6. Do I expect you to get 1 through 6 figured out on your own? No. I'm going to kind of go with you and do them. And then once we write them all down, then I expect you to soak it in and go over 1 through 6 and study them. So starting with number 1, if parallelogram, then both pairs of opposite sides. We've already talked about this. By definition, parallelogram, both pairs of opposite sides are parallel. So we've already talked about that. So that is going to be our first property of a parallelogram. Moving on to number 2. If parallelogram, then all pairs of consecutive interior angles. So consecutive interior angles. So if I'm looking at this shape, I said that both pairs of opposite sides parallel. So I'm going to mark that. I'm going to mark that with my arrows. So there's one pair of opposite sides parallel, and here's another pair of opposite sides parallel. Okay, so now if these opposite sides are parallel, and I'm not going to pay attention to this AC right now. Right now, it says all pairs of consecutive interior angles. So technically this angle A, this big angle A is an interior angle, angle B is an interior angle, angle C is an interior angle, and angle B prime is an interior angle. And it says consecutive interior angles. Consecutive, again, meaning adjacent, meaning next to. So these are angles that are next to each other, and they are what? Well, if parallel lines, then what can you tell me about these angles? Consecutive interior angles are supplementary. We learned this in Unit 3. If parallel lines, consecutive interior angles supplementary. I can say the same thing about B and this C, because A, B, and B prime, C prime are parallel. If parallel lines, then consecutive interior angles supplementary. Again, that's on the wording for proofs. That's what we learned in Unit 3. So if parallelogram, then all pairs of consecutive interior angles are supplementary. We now want to apply that. Moving on. Property 3, if parallelogram, then both pairs of opposite angles. Well, we just said that these triangles are congruent because of rotations and isometry. So angle B is going to be the same as angle B prime. Angle A is going to be the same as A prime, C, and C prime, and so on. So I can then say that opposite pairs of angles are going to be congruent. So B and B prime are congruent, and technically this A and C are congruent. If parallelogram, then both pairs of opposite sides. We already said we're parallel. What else can you tell me about their sides? Again, I just explained that these triangles are in isometry. So isometry meaning that the triangles are congruent. If the triangles are congruent, all parts are congruent. So that means the sides are congruent. So we have, or corresponding sides are congruent. So that means that I have this length is going to be the same as that length, and this length is going to be the same as this length. Opposite sides are congruent. And I said also that opposite angles were congruent. I'm marking this angle as my alternate interior angles because there is a line going through that. Put a little tick mark there to denote that these angles are different than those. If parallelogram, then diagonals, and this one you're not going to be able to kind of find from the picture. The term is bisect one another, and what bisect one another is going to mean. So we have one diagonal AC. I'm going to draw the other diagonal in as B and B prime. What bisect each other means, and if you remember bisect from way back in September, bisect means cut in half. And so I have this AC has been cut in half. I'm using 3 tick marks because I already used single tick mark and double tick mark. So bisect each other, it's been cut in half. That diagonal has been cut in half. And then this diagonal also has been cut in half. So that's what bisect each other means. And then the last property, if parallelogram, the sum of the measures of the interior angles, well, I have one triangle, so I have two triangles here. And I know that one triangle with the triangle sum theorem is 180 degrees. Well, that means I have two triangles, so 180 degrees, and then 180 degrees is going to give me 360 degrees. And so that's where that's coming from. If parallelogram, then the sum of the measures of the interior angles is 360 degrees. And that concept is going to kind of lead me into this last one. Going back to these properties 1 through 6, if you're a little confused on where some of them are coming from, that's okay. That's not my issue. Now that you wrote them down, you need to know them. You need to study them. You need to know what property 1 is stating, 2, 3, 4, 5, 6. You need to know them very well. I'm not going to quiz you on where it's coming from. What you're going to have to do is you're going to have to know the properties very well, apply them, because we're going to do some algebra problems with these properties. And I'm going to focus on the last property right now, an extension. So draw a picture of a quadrilateral that's not a parallelogram. You can draw anything. I'm going to draw something that looks like a trapezoid, I guess. It really does not matter. Predict the sum of the measures of the interior angles of this quadrilateral. Justify your prediction. So there's my quadrilateral, four-sided figure, not a parallelogram. And I have to figure out the interior angles. So what I'm going to do is I'm just going to cut this in a diagonal. And what two shapes do I have? So I have a triangle here and a triangle up there. So I'll call this angle 1, angle 2, angle 3. And I'll call this angle 4, angle 5, and angle 6. It really doesn't matter. But I know from the triangle sum theorem that this top triangle is going to be 180 degrees. And again, the triangle sum theorem that this bottom triangle is 180 degrees. So my prediction is that the interior angles, the sum of the measures of the interior angles is 360 degrees. And that's my reasoning because of the triangle sum theorem. And you can break any quadrilateral into two triangles. Thank you. We're going to now apply these 6 properties and kind of some algebra type problems to kind of apply the work and make sure you're understanding the definition. So if you have questions, please don't hesitate to ask. Thanks so much.